Hello and welcome to Binghamton University's Data Center Project presentation. Our project is the autonomous robot for monitoring and control of data centers. Now, today we'll go over who we are, the background of the project that we have been working with, what the problem is that we're trying to make a design for our design, along with the robot, some tests we wanted to perform, materials, a schedule, and a summary of our project. So with who we are, my name is Zachary Haig and I'm the team lead, along with Amanda Pelkey and Alex Schreiber-Harris. We're all senior mechanical engineering students at Binghamton University, and our project advisors are Professor Bruce Murray, along with Dr. Mohammed Tradat and Dr. Bharath Ramakrishnan. So some background on the project. This project is for the ES2 data center at Binghamton University. And this data center is a research data center. And they run tests and different types of experiments to test data efficiency and see ways that they can improve how data centers run. So some motivation into what the project is for is we want to be able to monitor what's happening inside of the data center, specifically inside of the plenum of a data center. So the problem, a definition of the problem that we're facing is we want an autonomous robot that is capable of reporting real-time environmental data through the use of several sensors. Now, for this, we'll just have to consider some of the physical constraints that we have with our robot and avoiding some obstacles that the robot would face in its environment. Now, to the bottom, we have a picture of the data center's plenum, which is an underfloor area where there is cooled air, which is passed through to help keep the data center cool and to not overheat. Now, in the picture on the left, we can see some of the supports that we'll need to avoid. And on the bottom right, we see a image of an overall layout of the data center, which on the next, we have a larger image of. And in this, we can see that there are these server racks, which are in the middle of the data center, which host the servers responsible for carrying out the research that the data center is doing. Now, in between these server racks, there's a cold air aisle, which handles the cold air, which comes up through the plenum to cool the servers. Now, this plenum is an underfloor area, which is supplied with cold air through the computer room air handlers, which provide a cycling of the air to maintain a cool environment. And so now we can see kind of the circulation where the cold air comes up through perforated tiles and helps to keep the data center cool. So now I will hand it on over to my teammate Alex, where he can give us more of a description of what our design is and how it handles the problem that we were faced with.
Thanks, Zach. For our project, we're using an iRobot Create as the base for the system. This provides mobility to the system as well as being the location where all of the other components are stored. Connected to this is the Arduino Uno. This acts as the control center for the entire robot. And this also controls the sensors, which will be used to measure temperature, pressure, and humidity, as well as the data output program used to output data to a computer. As I mentioned before, we're using the iRobot Create 2 as the base for our project. We chose this model in particular due to its high customizability. It has drillable areas on the surface, which we will use to attach the sensor mount, as well as a replaceable bin that can be used for additional storage. We're using the Arduino Uno Wi-Fi Rev 2. We chose this particularly because of its Wi-Fi capabilities. This will allow us to connect directly to the internet from our iRobot, and it also allows us to connect to a secure IP address and output our data to that. We needed our sensors to be able to measure temperature, pressure, and humidity. And to do this, we're using two sensors. The first of these is the DHT22 temperature and humidity sensor. This is capable of measuring temperatures from -40 to 80 degrees Celsius and humidities from 0 to 100% relative humidity. To measure pressure, we're using the SEN 12909 SparkFun pressure sensor. This can measure pressures from 0 to 1400 kilopascals and can operate in a temperature range of -40 to 85 degrees Celsius, which the plenum falls easily within. Here we have a circuit diagram of our Arduino. You can see that connected to the Arduino are the temperature and humidity sensor, the time clock, the pressure sensor, and the SD card adapter. We need the time clock in order to record the time that each of the measurements is taking. And we are using the SD card adapter as a backup for our data that is exported to the IP address. Now I'll hand it off to Amanda to go in more about the sensor mount.
Thanks. So first I'm going to go over in this design description the sensor mounting. So the sensor mount is composed of 3 pieces. Each will be 3D printed individually and then assembled together. You could see it in the image on the bottom left here, starting with the part on the bottom, the base container in gray. This is going to be what's holding the Arduino and also what's drilled into the iRobot Create at the specified drilling locations, which Alex had mentioned. Connected to this in green is the adjustable support arm, and then in blue the sensor platform. So each of the sensors will run along up this arm and be placed atop the sensor platform. It'll all be connected using a series of zip ties and Velcros. The adjustable support arm can be adjusted to different heights, which will be useful if in the plenum they want to take these measurements at different heights there, or also if the robot is used for different applications eventually. It could be good to have different heights of the sensors for that. The image on the right is showing what an assembled version of our robot may look like. This was a project that we found online, kind of similar to ours, where they used a robot at the base in white, and then attached that as a black box, which is where all their controls were. Then they have a sensor arm as well, which is a black pole on the right there. So then going into our data output program. So the measurements are going to be taken at different locations throughout the plenum and then exported to an IP address using the Wi-Fi capabilities of an Arduino. So on that address, you'll be able to see real-time readings of the temperature, pressure, and humidity in the plenum at each of the locations, and also scroll through this website to see the history of all the readings. The data will also be saved onto a micro SD card with the date and time taken for records and just to have a backup of all of this data. So now going into programming the robot, we chose to make the code in C++ because it is a very stable and fast code, and it's often used in programming microcontrollers. So it was best for this project, and we're using this along with different functions in the Arduino library. So the programming was split into 3 main sections amongst the team. So it was split into programming the iRobot movement to have it controlled to follow a path in the plenum, the sensor reading, so that as the robot stops at different locations, the sensors will take a reading for temperature, pressure, and humidity, and then the data output program so that each of these measurements are exported to the IP address. So the code was first compiled from similar projects that we found online with open source code. We were each mechanical engineers, so we had limited exposure initially to using C++, and this was our easiest way to start out with writing the program, but we then went into modifying the code for our given project requirements, and to do this, we also discussed with other people who know C++ how to best adjust the program we had. So once we completed the program for this project, we then went into coming up with proposed tests, which we never actually completed due to the current events, but one of the biggest tests that we had hoped to complete was to ensure that the robot would not collide with obstacles and that the data output is accurate. We were going to go into an empty classroom and use masking tape to kind of lay out the path that the robot would be following in the plenum. Because in the plenum you can't really see with the tiles where the robot is moving, we thought it would be best to do this in an empty classroom and just modify the experiment to just show what it would actually look like, so we can visually see where the robot is moving on this path and make sure that it's staying in line. So after placing the robot on the starting location and initiating the program to start movement, we would observe the robot and make sure that all the data is also being output to the IP address accurately. So this is our bill of materials for the project, which just goes over a summary of everything that we used. So the main expense was the iRobot Create 2, which was $200. Other expenses came from the sensors, from the Arduino, etc. But in total, the cost came to $370, and our budget was $600 for the project. So we did have extra money in case any equipment was needed for our testing, or any other parts were needed for the robot. So this is an overview of our project schedule that we followed. In the fall semester, that was primarily the design phase of our project, where we first completed a document for project specifications where we had to go over the requirements. We then created a conceptual design for our project. We completed a makeability review to ensure that we would be able to produce this design. And we then had a design report and presentation. For the spring semester, which was the build phase, we first ordered and acquired all the parts needed. We then went into building the project first on a breadboard to make sure that all the circuits were running properly, and then soldering the components together. Testing and optimization was then completed, or would have been completed, to ensure that the program was running accurately and to troubleshoot any code. And then we have a final report and presentation due in May. So in summary, through this project, we were able to create a autonomous robot which would move through the data center and report on the temperature, humidity, and pressure in the plenum, so that these measurements could all be analyzed and see if there's any changes needed to be made in the cooling operations so that the data center is running efficiently. We used an iRobot Create as the base, which was controlled by an Arduino Wi-Fi Uno, and then we had sensors connected to the Arduino, and all of the data was exported to an IP address. So in total, we spent $370 out of our $600 budget, leaving room for any additional parts for testing that were needed. So that concludes our presentation. If you have any questions, we're happy to answer.